What are the real pain points that led to the creation of these formats?
I think Wes McKinney has tweeted 15 years ago that big metadata is the next big problem, and I agree. That's why we should just use the formats that we have to deal with data, also deal with metadata.
I have this sort of analogy, and I was wondering what you think of it as. Iceberg is the new Hadoop.
And it's not that we don't want to add write support, but it's really just that these formats are challenging.
You mentioned that Avro should die.
One of the things in DuckLake that we managed to do is to cut, I want to say, like 15 technologies out of this stack.
Hey, everybody. I'm Jordan Tigani. I'm here with Hannes Mühleisen. And we're here to talk about DuckLake. If you were hoping that we were talking about something else, then this is your time to go and do something else with your morning, afternoon, whatever it may be. Hannes is the creator of DuckDB. Hopefully, folks have heard of the new hottest, coolest database in town. And recently, he and his co-founder Mark Rosveld. I'm not good at pronunciation of anything that isn't American. But anyway, he and Mark have created a new open data format called DuckLake. And I'm Jordan Tigani. I am the co-founder, CEO of MotherDuck, and we are building a cloud-hosted database using DuckDB. And we are very shortly to be announcing a hosted DuckLake version as well. We can talk about all that stuff a little bit later. Anything else that I missed? Hannes is also CEO of DuckDB Labs. He is a boating person. How many boats do you have?
It's difficult to say. There's two big ones, and then there's one medium-sized ones, and then various small ones.
I think boat people are like bicycle people. It's like you assume that they only have just the one, and then it turns out that
it's a bit of a disease, I have to say. But I mean, it's very fitting for today because in Holland boats do float on lakes. So
yes, and there are ducks in some of those lakes.
There's also many ducks. Yes. We've seen several.
So open data, start with a little bit of context, just to make sure that we can kind of level set for everybody. Open data formats, everybody is talking about Iceberg.
Yeah.
Every once in a while they'll say Delta, but mostly it's Iceberg these days. So tell me what are these open data formats and why is everybody talking about them?
Yeah, so basically everybody got sick and tired of blockchain and then they needed something new.
What about AI?
Oh, God. Don't get me started. But no, in all seriousness, I think open data formats are a technology, first and foremost, a set of conventions that kind of describe how maybe data management systems want to exchange or integrate on table data between each other. So I think it's an attempt, of basically breaking up these silos of data that we know so well. We've been talking about people holding data hostage for a long time, and I think it's still a very viable business model to do that. But I think the open table formats are in a way a reaction to that. You basically describe how you want to represent tabular data mainly in files, and then you have a standards committee, essentially the most beautiful thing that exists, a standards committee, basically guarding the standards so that people kind of play along. I think that's how I would describe it.
So I've been an engineer and a product person, and as a product person, you often look at okay, what are the actual user pain points, and what are the use cases? What are the real pain points that led to the creation of these formats? And you mentioned kind of the lock-in and but those don't seem like serious enough to generate the kind of mania that we've been encountering.
Interesting. I'm very old and jaded at this point regarding what creates mania and what does not.
We are living in the Netherlands, which maybe invented.
We invented manias. Yes. The tulips and such. I know, but I think the user pain points is an interesting point because I think it's a great way of looking at it from a blob store. From a user perspective, from a product perspective, I think what it came from this other direction, not from the data warehouse side, but from the data lake side, right? Or as like to say, data swamp side sometimes, where people, as an evolution of the Hadoop era, where we had large amounts of files sitting on like some storage system, there was a bit of unruliness maybe, and then the pain point I think was updates, right? How do you reason about change in things that are in a data lake? I think that's where I say would be the pain point that they're trying to solve.
I think the funny thing to me is that these formats started as ways to have to do updates in a meaningful way, but that's actually, it doesn't seem like what all the Iceberg people are actually care about. Like Goldman Sachs is a big Iceberg customer. They're like, we're all in on Iceberg, but like I don't think they have trouble doing transactional updates, and that's not why they're all super Icebergy. I'm trying to like dig into the
why does
what
it
is
exist?
what is the like. I mean, because I wrote a doc for the team about like, hey, we need to take these data lakes and lake houses seriously, and I had like an intro section on Iceberg, and I said people love Iceberg, and like my team wouldn't believe me, because they're not database users, they're database developers, and like because it's like, okay, what is the use case?
What's the use case? And I think there is one that I can really see, because I've also been thinking about this a lot in the last couple of months together with Mark, obviously. And one thing I can see is that storing like data you're not like really looking at in a traditional data management system is insanely expensive, right? The markup for storage, I mean, I'm not going to tell you what your markup for storage is, but there is, if you look at Snowflake, if you look at BigQuery, there is a markup on storage. And it's quite steep, and it's way worse in traditional systems like Oracle or something along those lines, right? Like they will charge you an insane amount of money. And it's not only that, it's also the kind of hardware you need to run these systems, right? So these are like triple redundant power supply, I don't know how many network cards, like hand sort of held by like a staff of engineers, and then you're putting data there that you're not really looking at. And that's not great, right? Like only the richest organizations can kind of do that. So the open table formats, I think they are solving an interesting thing there, where it's like, okay, we can put our the data, the stuff that we need to keep around, but we're not looking at very often on like a blob store, on like S3, something like that, at like fairly low cost actually, and it's still going to be look to us more or less like a table. It's not like that we have to suddenly go into this like file world that is a bit unruly again, right? So I think that the price difference in terms of storing data that's like more historical, I think that's a huge driver for, if you look at big organizations, I think that would be an interesting aspect.
Yeah, I mean, I think there is something to that, although like Snowflake, I think they've said they're not trying to make money on storage. BigQuery, we didn't want to make money on storage because the thesis was like, the cheaper we make storage, the more people will give us, and then the more they'll query it. But especially if stuff is just sort of sitting there mostly quiescent, like you might as well store it. I think the other thing that we've seen is it seems like, especially people who have a lot of data, they tend to use like a Snowflake and a Databricks, and they have their AI workflows and they have their data warehousing workflows, and they want to be able to operate over the same data. And I think that's sort of the other.
That's definitely an aspect, yeah. And I think that's also fair, right? Like, and again, I mean, I have to disagree with you on we don't want to try to make money off of storage, but like a single scan over this is gonna be expensive.
Yes. Well, that's yes.
So yeah, okay, great. You're still engaging in data hostage taking, even if you're not putting an enormous markup on storage. The end-to-end cost of looking at this stuff again is going to be big.
Yes, I totally agree. You mentioned I'm not sure if it was elsewhere or when we were chatting the other day that you had an aesthetic reaction to Iceberg. Mm-hmm. Can you tell me a little bit about that?
Yes. So we at DuckDB Labs I would say like we aesthetics of databases. I don't know how we ended up in that position.
Would you call yourself an aesthetician?
No, that sounds a lot like somebody that does nails. Not that is terrible. I'm just saying that's not what I am. You don't
manicure your database?
No. I think the aesthetic sort of focus came from actually working in research and trying out a whole bunch of different systems, and then basically cursing, for a day until you get something running, and then just to get like one data point, right? Mm-hmm. So for us, the cost of setting something up versus the time you're going to use it was like very skewed to the setup cost, because we needed like to run one query to see how, what on earth DBMSX is doing, right? So I think maybe that has led to the aesthetics. But what is the aesthetics problem with Iceberg? I think initially the idea of Iceberg, and for those who everybody has seen this one picture, right? Where you have like the arrow on top, and then you have like the JSON file, the Avro files, and then you have the storage files on bottom. I could sort of see that, right, when it first came out. That was fine. That was not great. I mean, I still don't understand for the life of me why I picked Avro for this. Mm-hmm. It's a format that should die, in my opinion. There's better options around. But okay. But the aesthetics issue really started when they slapped the catalog server on top to solve some really fundamental issues that people were running into. Mm-hmm. Because the format was designed, the entire notion of Iceberg in the beginning, the V1 or whatever it's called, was to say we only need an object store and we only need a bunch of files, and that's it. You don't need more. That's it. You need you need like the credentials to read those files, and then you can do anything to that table. But that changed for reasons we can get into if you want. And then they ended up putting this catalog server on top that completely broke with that design philosophy that up until this moment had been fairly sane, right? Had been at least clean, aesthetic, right? Like we have an object store and we make tables happen object store. Okay.
You may disagree with the aesthetics, or there might be,
You might disagree with the approach, but like the design was fine. Again, we can talk about details. But like for me, that was such a radical change to put this catalog server on top, because now there's like another piece of infrastructure that you have to run to make this work. There is, there's like some Java gunk. I'm sorry for that. There's some Java gunk that is like exposes like a REST service, and then that needs to talk to a Postgres server that's running in like some fleet of Docker containers. It's like, this seems wrong. I think that was like where this whole broke down for me.
Yeah, I remember being at Cider in Amsterdam a couple of years ago, and I was talking to one of the Databricks engineers who was working on Delta Lake, which is the Databricks equivalent of Iceberg before Databricks said no, it's all our pie. The only thing they left out was Hootie, I guess.
Yeah.
And I said, well, why don't you just put all this stuff in a database? And he was like, well, databases are totally verboten. Like we cannot use databases. I was like, but aren't you going to have
why
to
not?
Well, and then they go and they added a database, and I think that's one of the interesting things about like systems is when you start with a constraint, and like you build under a constraint, and then you remove that constraint. What are the other things that also you would change? And I think I will get to DuckLake in a little bit, but I think that's sort of one of the reasons that that DuckLake actually makes a bunch of sense.
Right.
So we were. I have this sort of analogy, and I was wondering what you think of it as like Iceberg as the new Hadoop.
Anything to make Hadoop look bad, I'm happy to participate in.
You're not a Hadoop fan?
I'm not. No. But I was running it for a while, so I'm qualified to talk.
But I think Hadoop was super popular for a while, and everybody had a Hadoop strategy, and it was actually the number one thing. If you were the number one highest paying skill you could have as an engineer was somebody who knew Hadoop. Started a bunch of companies, and then I think the underlying the architecture was wrong, and then Spark came along, and it was actually a much better way of doing the same things. And also there was this sort of fragmentation. Nobody, there was Cloudera and MapR and MapD and Hortonworks, and I sort of see the same thing with all this, the catalog wars, and everybody kind of having their own catalog because now if you can't own the data, you can at least own the metadata.
Right. I think I like the comparison to New Hadoop. I mean, it's certainly from the Hive perspective, right? That it is something that people don't question. I think this is also something that disturbs me, and in general in computer science actually, that we are as a field not very critical. We far too easily say, this is what this thing does. Okay, fine. Right? It's not like I sometimes teach at university, and I try to tell the students to really start questioning this, because in a big difference to many other fields, nothing that we do is actually written in stone. Software is just bits, right? You can do whatever you want to it. So that's, I think, but to the comparison with Hadoop, I think it's certainly the thing you want to put on your CV right now, right? I know catalog servers if you're in data engineering, for sure. The hype, for sure it's there. But the difference that I see is that many of the problems of Hadoop were the implementation based, and were not, let's say, inherent to the concept. Right, I know that Hadoop is yet one of these examples of somebody misinterpreting a Google paper and then making a terrible implementation off of it, right? But many of the problems came from the terribleness of the implementation, in my opinion. And that is not the case with Iceberg. I think Iceberg's problems are conceptual, fundamental, in baked in the specification, which is an entirely different way of being wrong, right? In my opinion.
That makes sense. There was a meme that's surfaced a couple times, and I was wondering if maybe you could help resolve this. There's the meme that the reason that DuckDB doesn't have Iceberg write support is because you don't care.
Oh.
Or is because you hate? Is because you're off working on your DuckLake and
yes. That's absolutely true. I'm obviously evil. This is very true. That's
why you wear black shirts all the time.
I have a little and I have a little nephew who lives in California, and he has pointed out that the Germans are the baddies. So that makes total sense. I'm the one person that's in the way of widespread Iceberg adoption. Right? That makes total sense. No, okay. The thing is, it's not that we don't care or that I'm evil, because it is something that people have requested from us a whole lot, and I'm happy to tell you that we have in our lab at DuckDB Labs, we have gotten Iceberg write support to work for the first time, I think, last week.
Woohoo! You heard it here first.
I heard it here first. And I think that's surprising to me that it took that long. Yes, and it's not that we didn't care. In fact, we care very much what people want. I mean, we look at that a lot. It's one of the inputs in our roadmap. We said, okay, people want to do XYZ. We'll try to do XYZ. And me personally, I wrote the first Iceberg reader for DuckDB way back when it first became a thing, because we were like, okay, there's this new thing, let's try to understand it. And we tried to, there was an internal presentation of theirs, thankfully there's no video of that, where it's just like, how on earth is this supposed to work? Like, it's extremely difficult to make a competent or a functional Iceberg writer. It's even more difficult to make one that's like, maybe supports compaction or some sort of cleanup procedure and doesn't just, explode this JSON file on top. It's extremely difficult to get correctness right? Like, I mean, this is a system that's deeply ingrained in like storage, in like the catalog now, in your internal sort of transactional operations, like staging all those files reliably, then, doing a commit into like it's hard. I think the reason that we don't have it yet is not that we don't care. In fact, we are working with many parties that are actually paying us to implement this at the moment. The same is also true for Delta. And it's not that we don't want to add write support, but it's really just that these formats are challenging, I would say, at the very least.
Yeah, I think that's one of the underappreciated things about these formats is that it's incredibly hard to build writers for them. I mean, like readers, which is actually funny because a lot of times, like, it's easier to write things than it is to read them.
Often,
it's like, you write JSON, you just blast out a bunch of JSON. I guess maybe anyway, but like in order to build the correct one, you have to be able to compact on Iceberg compacts on writes.
No, it can do both. It depends.
And then you have to have like, build in like some sort of transactions and locking and back off, and what happens if two people are writing the same thing at the same time, and like you basically have to build half of a database.
I don't think you have to write half of a database. You have to write an entire database. Like, what is missing that a normal database would have? Like, give me the one feature that like Oracle has that, like, okay, Oracle has a million features. Give me one feature that like a normal data warehouse has that an Iceberg plus catalog plus Spark doesn't have, right?
Yeah, I mean,
I can't really.
Expression evaluation, or do you have to do that for
sanity? Maybe, I don't know. I mean, like, yeah, but anyways, no, but expression. No, the evaluation in the scans. But the engine, I mean, that Iceberg doesn't do that. The engine that reads it does that, right? Mm-hmm. So they can do it. It's not the format that cannot do that. I mean, it is very challenging. It's like this perfect storm. You're sitting between like blob stores and distributed store execution, and you have this catalog thing that's like constantly changing extremely fast for anything in data. And I also have to be good at extremely like complex basic things, like making a Parquet writer that works is difficult. I mean, we started working on our Parquet integration at DuckDB 5 years ago, and so I would say it's now pretty okay, but it took 5 years, right? Mm-hmm. I'm not even to start about Avro, but it's challenging. It really is challenging, and yeah.
I think that's one of the underappreciated things, and which brings us to the topic of the hour, which is DuckLake. Tell me about DuckLake.
Yes, DuckLake is an instance of famous spite engineering at DuckDB Labs, where we think we know best, or better. Now, so DuckLake is basically acknowledging this development that happened in Iceberg and also in Delta. We're not discriminating. That they put a catalog server on top of this previously file-based structure. That catalog server and in turn contains a database server that does basically the hard part of transactional guarantees, like stores which tables exist and where they're stored and credentials and things like that. Mm-hmm. And we did a thing that we would have thought that they would do, which is reevaluate what you said before, reevaluate their design decisions about, how this thing needs to look like, based on this sort of acceptance or sort of resignation, if you want, to depart from their file-based structure, right? And so they said, we'll slap this catalog thing on top, but we're not changing anything else. Mm-hmm. Right? That's what they did. And I mean, it's all designed by committee, so I can totally see how that happens. But we went and said, okay, but what does this actually mean how would you design this if you accept the fact that you have a database for the metadata? What does this look like? And I mean, I don't have to explain this to you because you have worked on BigQuery, which is exactly doing that, right? Like you have your database. I think you have Spanner maybe now, but maybe it was something else back then maybe. You have your database that's storing which tables exist, what columns they have, and then what files are part of that table. And you have your sort of large, fairly cheap storage system on the other side that you basically read stuff from blindly, right? Mm-hmm. That is DuckLake, right? We'll just say, why don't we use a database? Which is not, we are extremely surprised that people think this is a good idea, that this is somehow revolutionary, because this is the most, in retrospect, in hindsight, the most obvious thing ever, right? Like you say, hey, here's all this complicated, interconnected data, metadata, of which we have to change small bits all the time, and then say, yeah, let's write a bunch of Avro files. Mm-hmm. Or you can say, well, that sounds like a job for a database, especially if you already have one, right? If you just added this thing, you added this, like in your diagram, you added this thing that looks like a stack of disks, right? And then what all DuckLake really does is say, let's move that up. And so what it contains of DuckLake, sorry, I get very confused at this point. DuckLake is a specification, essentially, of a database schema, some tables for tables. It's Inception.
It's tables all the way down.
Yeah, exactly. And tables of tables, and tables of columns, and tables of files. And we also have some just documentation, specification, what these things should contain. And then with that, you can build a Lakehouse kind of thing using just the database for the metadata management and an implementation. Mm-hmm. Also, because we don't like design by committee that invents things that nobody implements and makes life harder for everyone, which, by the way, I think happened a lot in Iceberg. We also have implemented an extension for DuckDB called the DuckLake extension that essentially implements this specification, the conceptual thing. So basically, if you install in DuckDB, you can install this DuckLake extension, and then you can connect to a metadata server. That we can talk about that in more detail, what that looks like. And you can connect to a file storage thing, and you can run queries and updates, and it's all good.
I think one of the amazing things, because we were talking about how long it takes to build these things, was that I remember talking to you and Mark, and I think Mark had just decided, or maybe it was you that decided to spend a weekend kind of hacking on this, kind of at the very beginning, and that wasn't very long ago. In the meantime, so you designed and implemented this thing. In the meantime, you have
a company to run,
multiple engineers working on sort of an Iceberg implementation and writes, and you're able to get this done faster than the Iceberg writes, because it is just so much simpler. And I think that's the thing that's easy to miss, is that there's a really, really elegant simplicity to this. It's just sort of you've got Parquet files. Okay, everybody has Parquet files, and you've got a database.
Everybody has a database,
and it doesn't matter which database it is, and then it's all defined. The specification, of my understanding, is actually a SQL specification.
Right.
The types, the tables, and so
queries.
In order to implement a DuckLake connector, all you have to do is write some SQL queries, or write
Yeah. You can copy ours. Yeah, exactly. So I think we are really excited about other people implementing DuckLake support, and it is really simple. You have to be able to talk to a database. Very often that will be maybe a Postgres server, right? Which is great for that. And that is, I think everybody knows how to do this. I think every engineer out there will be capable of this. And the other thing you have to do is you have to read from BlobStore and write to BlobStore. Parquet files, not 15 kinds of files, no, just Parquet files. Again, that's a pretty common thing. Mm-hmm. So again, back to aesthetics. I think one of the things in DuckLake that we managed to do is cut, I want to say 15 technologies out of this stack. Mm-hmm. Right? There's no Java for the catalog server.
Woohoo.
There's no REST. There's no REST. There REST protocol to do changes to said catalog server. There is no Avro. There is no JSON. There is no, what else have I forgotten? There's no Spark, maybe. But essentially, like, there's a long list of things that you don't no longer have to do, which really lowers the cost of implementing something, right? And yeah, it is in the end, you can just talk to the metadata server, you get the list of Parquet files to read, you get the list of deletions to read for a specific snapshot, for a specific table, and then you go and run your query. It's not rocket science.
And I think from the implementers and connector implementers perspective, it's clean, it's simple, it's elegant. But then also from the user perspective, like you were telling me, like what are the steps that you need to do to get a DuckLake up and running? All
right. So this is very complicated, I want. But we have a 3-step sort of program to get DuckLake up and running on on a MacBook, for example. So you have to install DuckDB. It's you have like a command line one-liner that you can use to do that. It's like a 40 megabyte binary. It's really not difficult. You have to start this binary, step 2. You have to launch a binary. Some people find this challenging, but you have to start a binary. And then you have to basically just type attach DuckLake something. And that's like the 3rd line you type. And that's it. That's your up and running. You can run queries, you can create tables, you can do all these wonderful things that you can do with Lakehouses. And it's a 3-line setup, and it will seriously just copy paste it from and it will be done, right? There's no I don't know. I'm so tired of setting things up, honestly.
There's not a lot of things that can go wrong.
Nothing. You don't have to do anything, and it comes back down to product stuff. I've been told this is a product thing.
Yeah.
But I don't know. I don't think it is. I think it's just aesthetics.
Speaking of aesthetics, somebody mentioned on the interwebs that that DuckLake was basically just sort of like, souped up Hive.
Yeah. Yeah, it's an interesting question, and I think it's I mean honestly I have not spent a ton of time with Hive myself. Did you?
I try to avoid it, but I mean I think Hive was the initial catalog. It was the proto catalog, but I think all it had was, I mean, just like what you described as the saddest table in the world. It points, I have a table, and it points to a bunch of files that are here.
Right.
And that's sort of its job, is to keep track.
Yeah, I think DuckLake is different from it in that we pull more things in the database, I think. So we have information about partitions in the database. We have information about files. We have statistics on a table level, on a column level, and on a file level. We have a lot of information in that database, and we have a defined way of doing updates. I think that's maybe the biggest change. I think updates in a Hive catalog are a bit like, I don't know how they do updates. Do you know how they do updates in Hive?
I don't know.
No. I think that's also, somebody told me, Hive kind of hit a wall because of the whole Cloudera Hortonworks drama that unfolded at the time. And I think there was like the essentially development sort of forked and never really recovered. I think Hive could have become DuckLake. I think there was definitely a chance. But it is. I think DuckLake goes further in sort of doing things in the database.
And I think that actually that there's an interesting thing about moving that statistical information and the range information and up into the metadata store, because then with a single query, you can do a bunch of the the lookups and the partition pruning,
everything.
Whereas in Hive, you'd have to you read to find the file path, and then you go to the file path to figure out what files are there, and then you have to read the headers, and you do the pruning based on the headers, and hopefully you have that cached, and so it's simpler, but like it's just a lot easier to do just a single a single
shot
query to get that.
Yeah. This is really cool. If you ever see it in DuckLake, I think we have some example on our website somewhere where, as you said, you know which filters are defined for your query, you know which columns are being selected by the table, and you basically throw all that into the SQL query you use to retrieve the files and let the database figure out which files to return. And with that list, you have a completely pruned and fully selected list, and you know these are the exact files we have to look at to evaluate this query, right? And I think that's pretty unique. That is a query that finishes in, a few milliseconds, like not 5 seconds, not 10 seconds. It's a couple of milliseconds, and you get back a list of files, and that you go out and read those. Yeah,
and you actually can put it in the in the query path and have it be quite fast. A couple of years ago, I gave a talk about like how it seemed like with these open data formats, we were starting to build part of a data warehouse, but just in order to make it actually work, we're gonna have to sort of build more of it, because there were a bunch of things that were missing, like being able to do high frequency updates and being able to do small updates like streaming data in. And I think that DuckLake has solved that in a pretty cool way. Can you talk a little bit about that?
Yeah, I think updates are super interesting. I mean, it's the whole point of doing this in the first place, right? We want to do updates and we want to do schema changes. And in DuckLake, one thing for updates that's nice is that you spend much less time on a critical path, because you have basically you stage your files and then you run a transaction. And it's a transaction. Either goes through or it doesn't go through. You're not trying to write a file that then fails, or you have to check. You get all these funky conflicts. Postgres is pretty good at handling that, right? So you run a transaction. It runs a few milliseconds. It's fine. Postgres is easily able to run thousands of transactions per second. I have heard that Iceberg is struggling with like 1 transaction per second, even with a catalog server. That's a bit problematic. And another thing that Mark has actually invented, which is really funny, is that we can actually, DuckLake optionally can actually inline changes into database tables and then later flush them out to Parquet files, which is really interesting feature to have like high frequency updates. And the cool thing about that is that's not some strange Lambda architecture that's like always slightly out of sync. No, these are in the query path. They're fully transactional. You will immediately see those rows, even though we have sort of parked them in the metadata server for the time being. So there are some interesting things for high frequency updates. Another really big advantage of DuckLake is that the open table formats traditionally suffer with the amount of snapshots. Like in Iceberg, for design reasons, every single snapshot lives in the root file, in the root JSON file. Like every single snapshot that ever has happened lives in this file. And every single snapshot has the entire schema information, has lots of like interesting things. And so this thing gets really big very quickly. And so in order to fix that, unsolved problem, by the way, you have to start pruning snapshots and things like that. And in DuckLake, on the other hand, you can have 100 million snapshots. Not a problem, right? So that makes it much more suitable for like high frequency updates, right? Because you're not immediately running into this wall of only being able to realistically manage 10 snapshots at a time. No, you can, as I said, you can have 100 million snapshots. It's fine, right? It's just a table.
Sure.
I mean, you might want to set an index on that table at some point, but it's just still a table. So that is really cool to see. We did some experiments on that where we did have 100 million snapshots, and we could show that query planning on that is like a sub-second still.
Nice.
Which is,
Have you done performance benchmarking on DuckLake yet?
We did some benchmarking, like I just mentioned. We wanted to know, because people have scaling anxiety, right? You know this.
Yeah.
Does it scale? Like it's a battle cry of that I'm a bit over, honestly, because usually the people that are yelling, "Does it scale?" They don't actually have big data. But okay. So we said, okay, fine, but we're gonna get this question, so we're gonna do some benchmarks. So what we did is we set up a virtual sort of DuckLake setup with a petabyte of data. And then this was the experiment with 100 million snapshots on it. And it was simulating like a data warehouse over 10 years that gets like updates every couple of seconds with fairly sizable Parquet files. And then so we ran basically our query planning on that, like the queries that we have in order to do basically retrieve the lists of file to read and with sort of random predicates, and we could show that if you put, for example, if you put this in a DuckDB instance or in a Postgres instance with some indices, you'll be able to run this query planning in a sub-second, which is insane, right?
Yeah,
like
that's amazing, and because you have all the you store all the metadata about all the row groups and all the
not the row groups. No,
okay.
No, we didn't do the row groups. That was a design choice. I mean, we might at some point allow it as an option.
Mm-hmm.
The row groups are like an order of magnitude,
mm-hmm.
possibly two, on the metadata, mm-hmm. and it's a bit questionable whether the row groups will. I guess it doesn't save you. You
still have to open the.
You still read the footer. At this point, you have that information. Yeah. So you're gonna read the footer anyway because you know somewhere in that file is something relevant.
Right.
And then you know at that point. What we do store in the table, which is something that has bothered me for years, is the offset of the Parquet footer. Because that saves you an extra read on the thing. But I think Iceberg does this too, in fairness. But it is something that makes me very happy that we have the offset of the Parquet footer.
Did they fix that in in the Parquet v2, or like is that still
what?
Or so that you could read Parquet with fewer reads?
No, it's always an issue, right? Like in Parquet, I mean, honestly, also, again, I was the person that implemented the first Parquet reader in DuckDB. This is the thing that happens if you're two people, you have to do everything. But no, the format specifies you start from the back, you read the magic bytes PAR1, even for version 2, it's still PAR1. And then behind that, before that, if you want, there is the length of the footer. And then you go back by that amount of bytes and read the footer. And there is a trick of doing it quicker. You can guess, right? You can say, I'm going to guess the footer is going to be less than a megabyte. Mm-hmm. And then when you get it right, you have to be very careful about what your N is there, right? Mm-hmm. But you can guess. When you think we do that. Yeah.
It's good to hear that like DuckLake can scale to petabyte scale and petabyte scale tables, like
it doesn't matter, right?
Yeah.
And also I want to stress something here. Sorry for interrupting you.
No, go ahead. Because that's, I think, one of the people were nervous, have been nervous, like people reached out to me, it's like, oh, DuckLake, this seems pretty cool, but is it going to be able to scale? Yeah. Will it scale?
I'm telling you, we should get a T-shirt.
Will it scale?
I think this is we should get a T-shirt. The two of us would be good candidates to wear these T-shirts. But no, I think one really cool thing about the DuckLake spec is that we are agnostic of which metadata database you use. So if you want, you can put your metadata into BigQuery. Why not?
Yeah.
Right? Will it scale? Yes. You can put your metadata into Snowflake for all I care. It really does not matter. Like the specification says, you need to have tables and transactions and maybe primary keys, and that's it, right? So the specification is flexible on where you store your metadata, and any competent SQL engine, no matter how scalable till infinity, will be easily able to serve as a DuckLake metadata catalog. So yes, you can have as many as you want. I mean, show us. If it doesn't work, we want to hear. File a bug.
So DuckLake has been out for 2 weeks now? 2
or 3, yeah.
Any interesting feedback that you've got, or like how would you summarize the feedback?
I think we got overwhelmingly positive feedback. I think we have, like, it doesn't happen very often that we do something and people like cold email me and to tell me what a great idea that is. Doesn't happen a lot in my life. So that has happened actually quite a lot with DuckLake. I was impressed. There were some questions around. Okay, I think, and the most valid criticism that I saw was like, you're doing the XKCD thing where you're defining another standard, right? Like, why are you doing that?
Yeah.
And that's a fair point. We are in a way, we are sort of refragmenting an ecosystem that was in the process of defragmenting, right?
But I think, the difference between the XKCD thing, which is like, there's 27 competing standards. I'm gonna unify them all in one standard, and then now there's 28 standards. That wasn't what DuckLake is. Is like there's 27 competing standards, or like I think there were three basic ones, and that's like that keeps getting whittled down. But you're saying that these are broken.
Yes.
And so that I think is a little bit different.
I mean, it just means I may be delusional, right? this is entirely possible. No, and I think what is we also seeing, and this was just some announcements last week from Snowflake and from Databricks, is we're also seeing how they're shoving more and more things in the catalog servers, right? To do things like caching, to do things like managing snapshots in a sort of halfway sane way. But I think it's actually interesting because I think that's actually another huge departure from this concept of open table formats, because the more logic you put into the catalog, the more this is going to be under the control of one of the whoever vendor your catalog is, right? So in either Snowflake or Databricks. So I'm actually kind of wondering if this is like I'm not wondering. I think this is an attempt of a grabbing sort of authority back over data, right? That you can't have with an open data format. Really, right?
But it does seem like people who are working on these systems recognize some of the problems, and I think they're trying to retrofit some of the things back into the latest version. Because somebody said to me, "Is like, oh, what about Iceberg v3 solves all these problems?"
Yeah. I'm sure it does.
And it also seems like there's also a lot of responsibility in the engines that are implementing these things about like, hey, if you want to kind of do something sane, you need to cache all this metadata, and you need to you have to do. There's a lot more work that's involved in having to do sane things.
Yeah, but I think you said this, that there's really not a lot of competent Iceberg writers out there, right? I think that's also extremely interesting as a sort of observation. I mean, the thing has been around for, I don't know, 3-4 years, something like that.
Mm-hmm. There's like a Java implementation. There's a Spark implementation, like PySpark. I don't know, and I there's not. Everybody says like, well, why aren't there more implementations kind of sitting around waiting? It's not because nobody has tried it. I mean, because it's the kind of thing that people like to do. Is like, hey, I'm going to build like the Rust. Everybody likes to rebuild everything in Rust.
No comment.
Yes, why isn't DuckDB in Rust? We don't have to go there. But you'd think there would be more. But it's
strange. I think it has to do with what I've mentioned earlier, is that I really like how C++ does this in the standardization, where there has to be, I think, 2 compilers that demonstrate how something could work before they even consider it for the standardization. I think in Iceberg, there has not been that level of scrutiny on proposals for a long time. And so they would define, that's an accusation. I apologize if you work on the Iceberg PMC, but then you probably work at Databricks now, so you're fine. There's a lot of things I think that have not really gone through this like crucible of there needs to be an implementation that demonstrates that this can be done, or there needs to be an open source implementation that demonstrates how this can be done. I think that's one of the reasons why it's so complex. Parquet didn't have this for a long time, but now they do.
Oh, really?
So if you want to make a change to Parquet, you have to demonstrate two implementations, which I think is a great step forward.
Speaking of implementations, I this being a MotherDuck hosted podcast, we have a word from our sponsor is that MotherDuck, we're very excited about DuckLake. Our intent is to be the best hosted DuckLake. We hope there's other hosted DuckLakes. We hope that everybody uses DuckLake. I think, I'm an engineer, and I believe in working with great technology, and I do have an aesthetic response to technology as well. And that was what attracted me to DuckDB in the first place when we decided or when I first reached out to you and Mark and decided to build a company hosting DuckDB. But I think so at MotherDuck we're working hard on getting our DuckLake up and running. I believe it actually soft launched today. Ooh. But we're going to do the actual launch next week, and there'll be more on that. But so we're very excited to be in the DuckLake era. I think it solves a lot of problems for us, and it has I really like the consistency model that you can do lots of concurrent operations. Data's available immediately. It's scalable. It has partitioning. I think partitioning actually is going to open up a bunch new use cases, particularly around like scaling and like time series, and so a bunch of exciting things. And very happy that this exists, and wish it the best for the future. I think we have time for a couple of questions.
Great.
If I can figure out how to unlock my phone.
I mean, you're an engineer, you just said, right?
Yeah, that doesn't mean I'm good with technology. Alrighty. So first one, do you think that vendors will implement DuckLake? And is there an incentive for them?
Do I think vendors will implement DuckLake? Well, I hope vendors will implement DuckLake. I have just heard from one vendor. But I think that's going to be something to be seen. I think we should revisit that question in a year. I'm very hopeful. One of the reasons is that it is not that crazy to implement DuckLake. You need to be able to talk to a database and to an object store.
Yeah, I think it makes sense. You mentioned that Avro should die.
Apologies.
And that there are better options on the market. What are the options?
This is a great question. So obviously, for those who don't know Avro, it comes from Hadoop, actually.
Does it really?
Yes. It's one of these things that comes from Hadoop, like all good things. And it is a binary table format that is row-oriented, as opposed to Parquet, which is a binary table format that is column-oriented. The problem with Avro is that there is no access path that allows you to read a single row. You always read a whole block of rows, and most files will only have one block of rows. So at that point, you might be better off storing your data as a SQLite file, because then at least you have a B tree to find the row that you're looking for, or just acknowledge that you already have Parquet as a technology in your stack of the format that you're developing, and you might as well use that for those as well. I think Wes McKinney has tweeted 15 years ago that big metadata is the next big problem, and I agree, and that's why we should just use the formats that we have to deal with data, also deal with metadata. Why did Iceberg not choose Parquet for everything, right? That would have been a much better idea.
But I mean, if you're writing things out row by row, like Parquet is not a great format. Like, right, and you want to read. I mean, yes, you mentioned you have to read a bunch, and you can't just read single rows at a time. But it doesn't seem unreasonable to want to read in like row-oriented format.
Yeah, but again, like aesthetics, right? You're adding another technology that's entirely different and distinct to your format description. Like, I think you have to have a very, very, very good argument to basically add a dependency of your specification on another specification, especially on a half-dead format like Avro, right? Like, I'm sorry, I'm again not want to offend everyone, but the format is not active, has been not actively developed. Like there's years and years of pull requests like sitting around on the repo because nobody is maintaining it, and to basically build your modern table format on that kind of format, I think that was wasn't that move in my opinion.
And I have seen that like you can get really far with just compressed JSON. Like, especially if you're doing like row-oriented format, you don't get like
just use Parquet. Like, what's wrong with Parquet? Make the row group smaller, and then you have your sort of row-wise append. I mean, you don't have to kind of append. Also, yeah, in theory you can in theory you can append to an Avro file. That's just one sort of reason why it might be better for this. However, on blob stores you can't do that anyway, so you might as well forget about that aspect. So yeah.
Yeah. I think at Google there was an internal row-oriented format that I don't remember what it was called, but it was it was used much less in the last 10 years.
Parquet.
But
I mean, honestly, it's like answer to all data engineering questions. Just use Parquet.
Just use Parquet. Yeah. All right, you heard it here. All right, will DuckLake include access management? We're getting a lot of questions about access management.
I think it's an excellent question, and it's one that we predicted. So this is an excellent question. You want to be able to manage access, and I think there's some really great ways of doing it in DuckLake. So one is that you have your metadata server, and that you can use row-based access control on the entries on tables and the column and all these things to basically make sure that people can only see tables that they're supposed to see. There's another really interesting thing that DuckLake can do is we can encrypt each file with a different key that's stored in the catalog. So you can actually ensure that even if you have access to the blob store, you will not be able to read the tables you're not supposed to read because you have nailed this down. You can also use prefix filtering on the blob store itself, like DuckLake uses a predictable sort of file format like schema, table, file, and so on, which you can use to make it subject to access policies. And but I think somebody like MotherDuck is much better positioned to deal with to make this a bit more sort of intuitive.
Yeah, I mean, that's our plan. I mean, we're so we manage data, but we also want the files to be available through DuckLake. And so what we'll do is we will if somebody basically sends a request to get access to the files, then we will. We can. I mean, I guess this is what all the catalogs are doing these days. We will create signed URLs, and so basically give you a signed time-bound URL so that you get access to the the directory, and then you get access just to the files that are in that table. From a security standpoint, it does seem like the state-of-the-art access control in these Lakehouse formats is not awesome.
No.
But I think it is at least up to kind of the state of the art, and hopefully we can continue to advance the state of the art.
We also have a future plan to allow per column encryption, which means that you can even, because Parquet allows you to do that, and you can have a separate key for each column, and then you can have column level access as well.
Oh, very cool. Let's see. What are your thoughts on the Iceberg REST API?
Yeah, I think that it's interesting. Again, this is, I think, an anti-pattern personally. People have been yelling at developers for years that they cannot expose their internal database schema. It needs to be behind an API. I think by putting things behind an API, you're also basically you're basically condemning everybody to the access pattern that you have chosen. And I think is one of the strengths of DuckLake is that we don't tell you how to access these tables. You access those tables in whichever way you want. The Iceberg REST API follows the sort of traditional wisdom access pattern of you have to have an API. Okay, sure. It's not so much the API that's no. And the problem of having an API is that you need to have a service and you need to have custom code running. Somebody has to maintain that. Somebody has to upgrade that. Somebody has to sort of babysit that. And that's, I think, not ideal. I think our model is much cleaner where you have a Postgres server running that you talk to and you don't have custom code. I think that's my gripe with an API.
I think there's this constant tension between database people and developers. And database people are like, it's just SQL, write SQL. And if you look at Snowflake, all of the things that you can do in Snowflake are SQL. I think eventually they added a REST API because the developers got grumpy. On the other hand, when we started BigQuery, we built a REST API because we didn't know any better because we weren't database people. And then after that, everybody, all the database people told us we were idiots because we didn't do things in SQL, and it sounds like, this is just one more battle in the everlasting war, but between the SQL people and the REST API people.
It's entirely true, and I have another argument that I wanted to say is like you have a database already, whether you have an API or not.
Yes.
So by adding an API, you're adding another piece of technology to your layer cake, and I think that's the thing that you need to think very hard about.
Yes. Well, speaking of cake, I think we're out of time. Time to go, get dinner. It's dinner time in Amsterdam. I know it's breakfast time in these United States, or those United States. But anyway, thank you, Hannes, for spending this time. This was really interesting. I always enjoy chatting and geeking out about database stuff with you. And DuckLake seems like it's off to an amazing start. And I appreciate your time.